All right, guys, we are moving on into section 4.6. This section actually has a lot in it. Okay, we're going to spend a couple days in just this section. So this one we're going to learn how to solve by finding square root method, and we're also going to do completing the square. So we're going to do square root method today, and then we'll do a little more practice tomorrow with square root and start completing the square, and then we'll finish completing the square the next day. And then we'll spend a day kind of practicing it all together. Okay. All right, so finding the square root method, that's our focus for today. But before we get into that, your pink sheet has this on it, kind of a nice big pink sheet. This is to try to help you kind of organize what's going on. This chapter talks about the 4 major ways to solve a quadratic equation. Okay, so we already focused on factoring. That was the quiz we just took. You guys did awesome on. Today we're going to focus on the square root method. Then we're going to look at completing the square, and then eventually we'll get to quadratic formula. Okay, so I just want to kind of like have this for you guys. Every section that we learn, we're going to kind of jot down step by step how to do it. That way you can kind of keep each method separate. All right, so we already did factoring. What was the first thing you did with factoring to solve those equations? Before that even? Kind of. What's the word I'm looking for? What did you do with the equation? Did you move stuff? Yeah, it was in standard form. So you had to put it in standard form, ax squared plus bx plus c equals 0, right? That was the first thing you had to do. You had to put it in standard form, set it equal to 0. So after you set it equal to 0, then you factored. Remember GCFs, right? A lot of you guys don't like those things. And then you set each factor. So each factor equal to 0. And solve. So just so we can kind of have a way to kind of organize all this, because if you don't have a way to organize it, it all kind of runs together after a while. So I'm trying to help you guys kind of separate it, figure out which method is which method. When it comes time for your test over all this, you're going to have a 5-part test. You have 5 different sections to your test. One section having you do all 4 of the methods, so there's 4 of them. And then you'll have a last section that says solve using any method you want, but you have to use each method at least once. Now, these 4 methods, not everything can be solved with all 4 methods. So we're going to have to learn how to recognize what works and what doesn't. Because does everything factor? No, not everything factors. So we're trying to figure out, well, what do I do if it doesn't factor? What are some other options? Okay. First option we're going to learn today then is your square root method. So kind of hold your pink sheet off to the side for a second. We'll add to it in a minute. But back to your notes, solving by finding square roots. You can only solve a quadratic equation by finding square roots if there is no blank term in the equation. Any guess which term is missing? The b term. Very nice. If there is no bx term in the equation. So which equations are missing the bx term? So there's 4 equations up here. Which one's missing the bx? Good. This first one's missing it. Right, because that's part of your C term, right? Those would go together. And the last one, good, that's missing the BX. Here's the BX in this one. Here's the BX in that one, okay? So if it's missing the BX, then we can go ahead and use this new method. All right, to solve by finding square roots, you need to isolate the x squared. What's isolate mean? Good. Get it all by itself, entirely, completely by itself. Then you take the square root of both sides of the equation. All right, so go back to your pink sheet. Let's see if we can kind of write down a couple things here. All right, so step 1 is to isolate the x squared. If it's 4x squared, is that isolated? No. It needs to be completely, totally by itself, just x squared equals whatever else. Okay, so you're going to isolate the x squared. Okay, after you do that, you will take the square root of both sides. And then and a big old plus minus, and we'll talk about that because your answer will have a plus minus on it every single time. All right, this method's not terribly difficult, okay? So hopefully you guys are okay with this. It's not terribly difficult. All right, so if you come back to this, number 1, x squared minus 25. Ramon? Okay, let's kind of talk about what Ramon just did there. He factored it. Right, you saw this as a difference of squares? So he went x plus 5, x minus 5, right? That's how you would factor that, equals 0. Right, then you guys say x plus 5 equals 0, x minus 5 equals 0. Solve each of these. So x equals negative 5, and x equals 5. Right, 1 plus, 1 minus. That's what we learned previously, right? What the directions say. Ramon does that on a test. He's getting 0 points for that. Ramon, I was going to talk about that anyway, so I'm glad you brought it up. This is factoring. It's what we just learned. He's right, that does factor. But does everything factor? Is everything a difference of squares? No, it's got to be perfect square numbers for that to work. All right, so let's look at this the other way. What was your step-by-step that we just talked about? You want to isolate the x squared. You'd add 25 to the other side. So x squared equals positive 25. Once the x squared is by itself, we take the square root, because the square root is what undoes a square, right? So what's the square root of x squared? That's just x. What's the square root of 25? Now, wait a minute. Why did I only get one answer? But when I did it by factoring, I get 2 answers. It's a plus or minus. Anytime you guys take the square root of something, your answers are plus minus. If you are introducing that radical sign into the problem, your answer has a plus minus. Now, we've not talked about that previously because everything that we've done up to now was the radical already part of your problem. Look at homework from last night. Were the radicals already there? Yeah, so I didn't have to worry about plus minus. But anytime you are the one introducing that radical into the problem, because I'm the one who wrote that in there, it wasn't there to start with, then your answers are plus minus. It's minus half a point every single time you forget that plus minus. And it happens a lot. Ramon? Factoring totally works on this problem because the directions said to solve by finding square roots. Yeah, because when it comes time for your test, there'll be a section for each type of solving. So I'm going to be testing you on, can you solve using that method? Mm-hmm. Any method. There'll be 6 problems and 4 methods. So you'll have to use some of the methods more than once. Yep, and you can use whatever one works for it. It's totally up to you. All right, let's take a look at some more here, guys. Number 2, x squared minus 12 equals 0. So your first step is to isolate the x squared. So we have to add 12. So x squared equals 12. All right, your x squared is by itself, so we take the square root of both sides. So x equals, ooh, radical 12. Is that perfect? No. So obviously I couldn't have factored this one, right? Right, this wouldn't have been a difference of squares because that one's not perfectly square. How do you simplify radical 12? All that factor tree stuff we've been working on is coming back, so you got to simplify. Good. 2 radical 3. But every answer should have what with it? Plus minus. Because again, remember, we talked a little bit about your problems are starting with an x squared. So how many answers should you have? X squared. I should have 2. Yeah. Whatever your exponent is tells you how many answers you have. This is 2 answers. I have a positive 2 radical 3, and I have a negative 2 radical 3. That is 2 different numbers. Okay? All right, what about number 3? Okay. Doesn't matter which way I go? you're going to have to move two things regardless here. So I don't care, whatever method you want to go. First thing I heard you say was subtract 33, so I'll start there. So we get negative x squared. What's 6 minus 33? Thank you. Negative 27. Some of you guys need to work on your basic math there. Is x squared by itself? No. There's a negative with it. So you're going to have to divide by -1. Because, right, this is like a -1 sitting there. So that will cancel. We get x squared equals positive 27. Now is your x squared by itself? You want it totally by itself, okay? And we'll take the square root of both sides. So x equals good. It will be 3 radical 3. Oh, good. Plus minus 3 radical 3. Did you learn this method in intermediate? How are we feeling so far? All right. X squared totally by itself. And then take the square root. Don't forget your plus minus. All right. Take a look at number 4. I added a little more to it here. Got a little uglier. All right. What's your first step to get the x squared by itself? Ramon? Good. Okay, subtract 9 first. So 2x squared equals 4. Good. Good. So x equals the square root of 2 is 2. Point something, right? It's going to be a decimal. So can I simplify this at all? No. So it stays radical 2, and it's plus or minus. Because I took the square root, therefore I have to put a plus minus in there. I have 2 answers. Okay, one thing I notice a lot of students do is they like subtract the 9, and then they're like, yeah, I can take the square root of both sides. No, you can't. Okay, you have to make sure that x squared is totally by itself. So you have to divide by 2 before you do that. All right, what about number 5? What do you do with that one first? Okay, subtract the 3. Negative 5x squared equals what? Negative 12. Divide by negative 5. What do I write with that? Very good. 2 negatives make it positive, and it's just 12 over 5. Guys, when you're dealing with fractions and you're trying to take the square root of things, you do not want a mixed number. Okay, if I would change that to 2 2/5 and I try to take the square root of it, oh, no thank you. Okay, because when I take the square root of fractions, what am I actually doing? How do you take the square root of fractions? You do. Don't tell me you don't. You do. You take them apart. Yeah, you do the top, you do the bottom. So my next step, since this is by itself, is to take the square root. I take the square root of the top, and I take the square root of the bottom. Fractions are like 2 separate problems. You do them both. So we get x equals, good, the top will become 2 radical 3, just 5. Where'd the radical go? Let's go one step at a time here. Good, that is right. All right, so kind of going one step at a time here, okay? The radical 12, if you do your factor tree, gives you 2 radical 3. On the bottom, you have radical 5, which I can't do anything with that. But I can't leave a radical on the bottom, right? I have to multiply top and bottom by radical 5. Good, so that'll be just a 5 on the bottom. 2 radical 15 on top. And don't forget your plus minus. So all this radical stuff that we've been working on in the first unit, I made you refresh a little bit last night. It's all coming back again. And it will all semester long. The factoring, this chapter right here is like you constantly see this interwoven into every other chapter as we go through. Okay, all the same stuff keeps coming back again. All right, number 6. What do you do first on number 6? Subtract 7. 3x squared equals 23 minus 7? Good, that's 16. Then what? Divide by 3. Got to get that x squared totally by itself. So 16 over 3 divide? No, leave it 16 over 3 then. Good, take the square root, top, bottom separately. On the top, square root of 16? That's just 4. On the bottom, radical 3? Good. Right, I simplified the top to 4. The bottom I can't actually simplify. But I can't leave the radical on the bottom. So we have to multiply top and bottom. Good. The top is 4 radical 3. On the bottom, radical 3 and radical 3 is just 3. And don't forget your plus minus. Try number 7 on your own. All right, so notice when we're looking at this, guys, I want you to start trying to get in your head, I know we're going to start adding on a lot of methods here, but recognizing, and I look at that problem, there's no bx term, right? That's the only time this method works. If you have a bx, you can't just isolate the x squared because you'd have an x on the other side and it'd be a big ugly mess. So you only can use this method when there's no bx. All right, so number 7, what's the first thing we want to do? Subtract 19. So we get 3x squared. 3 minus 19? Divide by 3. X squared equals negative 16 over 3. That doesn't actually divide. Then what? How do you square root fractions? Top and bottom. Guys, I want to see 2 radicals in your problem. I want to see one on top and I want to see one on bottom. Okay? So then we'll get x equals, what's the square root of negative 16? Good, that'd be 4i. Remember that whole I thing, the negative under the radical? On the bottom, radical 3. Can't do anything with that. But I can't leave the radical on the bottom. So we multiply top and bottom by radical 3. So on the top, 4i times radical 3. It's just 4i radical 3. Good. Bottom's just a 3. And don't forget plus minus. So how many answers do I have? I have 2, right? I have a positive 4i radical 3 over 3 and a negative 4i radical 3 over 3. Typically a problem like this might be about a 3-point question. And then if you would forget the plus minus, I'd take a half point off. I mean, technically I probably should take a whole point because you've lost an entire answer, but I probably just do a half point. All right, questions so far? Are we doing okay? All right, number 8. What's first thing? Number 8. Add 2. So we get 4x squared equals, gives me a negative 15. Then what? Good. Divide by 4. So x squared equals, does that divide? No. So leave it negative 15 over 4. Then what? Take the I out of what? I don't have a negative under a radical. Your next step is to take the square root. I haven't done that yet. So there is no I until I actually take the square root of things. Okay? So we get x equals. He is right, though. There's a negative under the radical. So that's going to come out as I. Can I do anything with 15? No. So I radical 15 over 2. Just Put your plus minus on there, and then we're good, because there's no radical on the bottom now, so I don't have to worry about getting rid of that. Ramon? Mm-hmm. What you did is not necessarily wrong. It's just a long route, because then you'll end up with a 60 on top. So then if you do a factor tree on the 60, so you get 2 radical 15 over 4. So then 2 over 4 would simplify to 2 on the bottom. Yeah, so you'd still end up there. You just went the really long route. That's why I'm always like, if you can simplify your radicals first, simplify them first. It makes things a lot easier. Yeah, but simplify first, especially when they're perfect like this. So you save yourself a lot of work if you just simplify them right away. All right, number 9. What do you want to do first? Good, let's subtract 27. So x squared equals negative 24. Hey, there's no fractions, you guys. Yay. Then what? Square root. So x equals. Okay, so I radical 24. Can you simplify the 24? Mm-hmm. All right, so that's 4 and 6, 2 and 2, 2 and 3. So what do we get there? Good. 2I radical 6 plus minus. Can you see how that plus minus will be the death of some of you? Yeah, remembering to put that on there. All right, questions with all of this, because I'm going to kind of kick it up a notch then. I know. Sorry. All right. Sometimes they look a little different, okay? If you look at this problem, notice it's an x minus 3 squared equals 49. Do you have something squared? Yeah. No. No. Don't distribute. Yeah, don't distribute. Don't rewrite. Nothing. Right? You just want to isolate the x squared, or the parentheses squared. So instead of just an x, you have like a big old piece. But if I isolate the whole piece, then I'm okay. Right? If this was just x squared equals 49, if it was written this way, what would you do? Yeah, you would take the square root of both sides, and x would equal plus or minus 7, right? If it was just like that. This is the same idea, except instead of just an x, it's an x minus 3. It's a whole piece, right? It's in parentheses. The whole thing is squared. So we will take the square root of that. What's the square root of x minus 3 squared? Don't overthink this. It's just x minus 3. Yeah, just x minus 3. Right? The radical cancels out that squared, so all I'm left with is x minus 3. Square root of 49 plus or minus 7. Be very careful which part that plus minus goes on. Because I know a lot of you guys are used to, like, you write it down and you do a bunch of stuff, and then you're kind of like, oh yeah, I'm going to throw that on at the end. Be careful, because I'm taking the square root of 49, so that's where the plus minus goes, on the 7. Is this solved for x? No. I got to add 3. Now, let me show you how I'm going to write this, which I think will help you. Instead of writing the plus 3 underneath here, I think that confuses students. If you see it this way, I'm still adding 3. I'm just going to rewrite it in a different spot. X equals, so it'd be a positive 3 plus or minus 7. I'm not done quite yet, though. What's 3 plus 7? What's 3 minus 7? Negative 4. So my two answers are 10 and negative 4. No, I cannot do plus minus 10, because it's positive 10 and negative 10, both answers. No. Because if I would take a look at this, like I can check my answers, right? I can always plug these in. So 10 minus 3 is 7, and 7 squared, 49. That's exactly what the problem said. But if you would have plugged in negative 10, what's negative 10 minus 3? Negative 13. Is negative 13 squared equal to 49? No, it's not. Okay, so be careful where your plus minus attaches itself. Square root of 49 is 7, so it's plus or minus 7. And then when I'm finally getting x by itself, I need to move that over. Then I actually have like terms I can put together. Okay, so if you go back to your pink sheet for me, so we had isolate the x squared. In addition to x squared, I could also put in here, let me kind of shift this a little bit. So isolate the x squared or parentheses squared, because depending what your problem looks like, you'll take the square root of both sides, that's the same. Don't forget your plus minus, and then you may want to add on to here is get x by itself. Because like in that last problem, I had to move that 3 over. All right, let's take a look at number 11. Is the squared part, is it by itself? No. How do I get it by itself? Good. So I can divide by 2. Squared. Okay. So just like before, I still need to get whatever that squared piece is, whether it's an x squared or a parentheses squared, get it by itself. And then I can take the square root to kind of break it out here so I can do something with it. What's the square root of y minus 1 squared? Y minus 1. Square root of 25? Plus or minus 5, thank you. And then to get y by itself? What happens when I move that negative 1 over? Positive 1 plus or minus 5. If you would stop there, I'm going to take a point off. Okay, 1 plus or minus 5 is correct, but is it simplified? No. What's 1 plus 5? What's 1 minus 5? There we go. You get your 2 answers. Questions so far? Okay, take a look at number 12. All right, is your parentheses squared by itself? No. So what do I have to do? Good. Divide by 3. So I have x plus 2 squared. Good. 30 divided by 3 gives me 10. Good. So now my parentheses squared is by itself, so we can take the square root to undo that square. What's the square root of x plus 2 squared? Square root of 10? It's going to stay radical 10. What's attached to that? Plus minus. I can't do a factor tree. It's not perfect. I can't do anything with it. And then to get x by itself, move that over. Negative 2 plus or minus radical 10. Are those like terms? No. It's as far as I can go. Now, if you look back the last 2 problems we did, you didn't have a radical in your answer. They were just plain old numbers, so you can put those together. Here, one has a radical and one doesn't. They're not like terms. I actually can't do anything else. All right, number 13. Is your parentheses squared by itself? No. How do I get it by itself? You have good math sense. She said multiply it by 3. In my mind, that's what I was doing too. But what are most students going to do with that? They're going to divide by 1/3. It's the same thing. All right, most students I'll see actually divide by 1/3. It is so much harder. Those of you, well, people are calculator dependent. They'll type that in their calculator and get an answer. It's the same thing as multiplying by 3. But you should have learned fractions in about 4th grade, so now's not my time to teach you how to do fractions. If you don't know, use a calculator, type it in. All right, so 7 divided by 1/3 is 21. Then what? Square root. Square root of x plus 5 squared? X plus 5. Square root of 21? Plus or minus radical 21. Be careful there, don't lose those radicals. X by itself, negative 5, right? I have to subtract the 5, plus or minus radical 21, and I'm done. Had this radical 21 been an actual number, could I have gone by itself? Or I could have went further, right? Because if you look at the previous two problems, there was no radical. So these were like terms, so I could give you the answers. Here, there's a radical, not like terms, so I have to stop there. Questions, comments, concerns? Doing all right? All right, what about 14? You tell me. Can I do the method I just used? Yeah, I can use method. Can you isolate the parentheses squared? So we need to subtract 13. So I get x minus 3 squared equals negative 9. You guys got to be careful with those negative signs. Good. So your parentheses squared's by itself now. So now we can take the square root. Square root of x minus 3 squared. Square root of negative 9. 3i. Some of you, if you're like step by step, you would pull out that I, and then the square root of 9 is 3. What goes on here? Plus or minus. Don't lose track of that. And then to get x by itself? Is that 3? What happens to the 3 when I move it? Positive 3 plus or minus 3i. Can I keep going or am I done? I'm done. One has an I, one doesn't. Those are not like terms. You cannot put those together. All right, square root method. How we feeling? What must be missing in order for you to use this method? The bx has to be missing. And that'll be important that you recognize that as we kind of go a little further into all the other methods and start looking at all of them. Okay?